What gets me excited is the products and the objects that we'll be able to design a few years from now. I think we can hardly imagine right now because the capabilities just aren't put into practice yet.
I don't want to see barrier, I want to see opportunity. And what makes me very happy is I see around me huge potential. I can access knowledge that before was not there. That makes me enthusiastic because it helped me to realize my dream.
To me, future of making things is really an argument about disruption, and Autodesk not only putting a stake in the ground to define our opinion on where things are going, but also to set kind of a benchmark to shoot for, to guide our customers to be successful in a world of disruption.
Every day technology progresses, every day people have new problems and new opportunities emerge, and if we just focus on the things that are possible today, it really holds our customers back if they're limited exclusively by the things that our tools enable now.
It's about solving problems and helping people, and I think that's something that I'm just a small part of that, but it's such an amazing thing, and to work with all these great people, all these great customers, it's empowering to see the beautiful things that they can create that our tools are enabling.
Generative design lets you design things that weren't possible to design before. So the convergence of cloud computing, new materials, advanced manufacturing, and these new generative design tools are opening a new world up for designers to think and explore designs that really couldn't be done before. You speak in the language of goals and constraints. Basically, you frame the problem in terms of what you want the function to be of a design, and the computer generates objects to fulfill those designs. You get ideas out of left field as a designer where you're like, I would have never gone that direction. That's really interesting. I'm not sure if I even want to pursue it, but this is opening up my space of possibilities. The Hack Rod project, so we just took an off-the-shelf race chassis and put 56 sensors on the tension points of the chassis. The Hack Rod team drove that thing out in the desert under extreme conditions.
From there, that data was analyzed and input into one of our generative design systems, Dreamcatcher, and a new chassis was grown.
So this is one of the first times that data has been able to be gathered in the field on performance, fed back into the design to improve the design. So that's really a groundbreaking exploration.
As these things become easier, there are going to be more entrants in every market. 3 kids in a dorm room can start a car company. And what does that mean to the traditional car manufacturers? It means that they've really got to be looking at how they can start to adopt this stuff today.
The human brain can hold 5 or 6 variables at a time. The computer doesn't have that limit. So with generative design, what you're trying to do is put all these conflicting and dependent variables together, have the computer think about what are the optimal options, and present those back to the user. What I really think is unique about the elbow chair is that we're considering the manufacturing in CNC. So rather than taking everything to an additive output, putting constraints in for CNC machinery for milling was an important part of just realizing a beautiful and functional design, and using wood as a material just had a beautiful aesthetic output. What are the goals and constraints? Well, there's some weight, there's some balance, there's do you want the chairs to be able to stack? Letting the computer decide and give you hundreds of different options on that fit your preference, including the materials that you intend to build, I think was just a great creative expression in furniture design.
Immersive design is really the ability to explore really complicated options in true digital 3D, so as if you're there. I think a lot of the things that immersive design can enable is giving you a much better intuition about the outcome of your design before you build it. When you're able to truly design in 3D, you have superpowers that you could do things that you could not do with the traditional media of today. People need to make decisions on 3-dimensional information, and often it's not very intuitive to do that not at human scale. And when you have the ability to explore immersive design almost physically, it's at your scale, you're just getting so much more information. We have the Factory of the Future. It's a true industrial physics simulation of a digital factory operating virtually as if it's really there, giving me the ability to understand the efficiency of an entire line of assembly and how the parts would move. I mean, everything from the robots, the machines, to the forklifts running around, those are all simulated as if they're actually there. So you've got a much better intuition. If I laid out a factory like that, how is it really going to perform?
In traditional manufacturing, you need everything to be very, very, very controlled. Assembly lines with robots are not resilient. Once one tiny thing changes, it has dramatic impacts on the upstream and downstream of that factory. And if we can come up with better tools that can just absorb that complexity for you, so if there were sensors in your facility that could detect where your robots were, if you were to relocate a robot, or if you were to relocate the object that the robot needed to interact with, if you were to change the tool on the robot, if that was something that your tools could just sort of consume passively with sensor data, then you could start doing much more complicated procedures with robots and other tools.
During the process of manufacturing, we are collecting data. So for example, one of the components of the extruder bot is an advanced vision system that pretty much is based on a thermal camera. So we want to embrace the robot with an eye that cannot just look at the shape, but they can look inside. If I can look inside, I can inform the dream catcher that, look, these are the constraints, this is what I'm seeing. Okay. Although you want to follow this shape, I'm telling you that that shape is not possible. We are empowering the robot with the brain. So the brain, what means? Is made of different sensors. Sensors allow the robot to collect information, and then by applying machine learning, the robot can actually process that one, and then it can do more than just move, but it can actually correct and collect knowledge that later on we can use in our platform in order to improve the value and make this part manufacturable for sure.
My team is definitely interested in this vision of a future where robots are aware of their surroundings, are aware of the buildings that they're in, they're aware of the tools that are around them, they're aware of the people that are around them, and they're aware of what they've been tasked to do and ways that they could potentially do it. Our project with supervised high-rate metal printing is basically a MIG welder attached to a 6-axis industrial robot. And a MIG welder, for those that aren't familiar, is sort of like the hot glue gun of welding. As we are building up our print, we basically ask our robot to continually assess the state of the print. So the robot is aware of the final model that it's trying to accomplish. The robot is aware of where on the print it should have finished. And then with sensors, it can measure the actual print, and it can see that, oh wait, I should have been 30 millimeters above the ground, but I'm only 28 millimeters above the ground. If I continue and go up from 30, I'm gonna miss my weld. Because of that, we've been able to produce very large and complicated objects in a single attempt, because anytime something does go wrong in the print, and we were able to successfully resume the print.
In Autodesk, I see really the opportunity to provide to our audience a platform where they can really realize the dream, because I provide to them the knowledge that is going to ease their mind, and at the same time is going to capture what is in their mind, okay, and provide to them answer.
From the robotic fabrication to the generative to the immersive design, we have a next step where we can say, go talk to this space and go look at what's going on with Project Escher. Go look at what's going on with Stingray. Go look at what's going on with Project Fractal or Memento. It's not just a big idea that we put on PowerPoint and it creates anxiety, but actual tangible steps that our customers can start to take today.
We've got customers doing things that we never could have imagined just years ago. So it's about this community of people that have all really come together around designing, making, and using things that our tools are enabling, and it's really great to see.